Hello my dear students, hope you are doing well. I too can feel the excitement of paper discussion. The paper that you have taken on 17th July 2022, that is NEET UG paper, right? So this year I can't say, especially in physics, paper was okay. Like you can't say the paper was so easy, at the same time you can't say paper was so tough. It was just an average paper. So here is the very first question, that is the first question. Let's read what is written here in this. The de Broglie wavelength of a thermal electron at 27 degrees Celsius is lambda. This information is given to us. When the temperature is increased to 927 degrees Celsius, its de Broglie wavelength will become. Like let us suppose this is our initial temperature, that is T1. And at this temperature wavelength is lambda 1. This is our final temperature, that is T2, and at this temperature we have to calculate the value of wavelength. Is it clear to everyone? Good. Now hint is also given to us, that is you have to use de Broglie wavelength formula, right? At the same time, if you can recall this is a direct question came from our LN module, right? So you can also feel the importance of our LN module. That is even in NEET UG exam we are getting direct question from our module, right? So let's just start solving it. As it is known to everyone, since lambda equal h by p, where h is Planck's constant and p is momentum, and we can also rewrite this p as root 2 me, root 2 me, where m is mass, e is for energy, right? But here according to this question, in this situation you have to write a relation in between wavelength and temperature. But according to this formula you have a relation in between wavelength and energy. So from here what you can write? You can easily write it as therefore, or this imply that wavelength is inversely proportional to root under of energy, right? Now I am going to write one more relation, that is since E equal 3 by 2 into Kb into T, where Kb is Boltzmann constant and T is temperature. Now from this relation what we can write here? We can easily write here E is, that is energy, is directly proportional to temperature. Therefore wavelength is inversely proportional to root under T. Is it clear to everyone? Now I am going to this relation, I am going to use this relation to solve the question, right? As here I have already mentioned the initial temperature, that is Ti equal 27 degrees Celsius. So the very first thing that you should do is to convert this 27 degrees Celsius into Kelvin, because we usually use what? SI format for our solution, right? So what I am going to write here, lambda 1 by lambda 2 equal root under T2 by T1, right? Therefore lambda 2 will be equal to lambda 1 into root under T1 by T2. Right? Now I am going to put the respective values that is given in the question. That is, at the place of lambda 1 it will be lambda. At the place of T1 it will be 27 degrees Celsius. That means 27 plus 273. So it will be 300, right? So here directly write, let's 300. And T2 is what? 927 degrees Celsius. That means 927 plus 273. So it will be 1200, right? So after solving this part, what you are going to find? You are going to find it will be lambda by 2. And the same thing you can see here in the option number 2. That is written there also. That is option number 2 is the correct option. Hope it is clear to everyone. Here is the question number 2. That is, the ratio of the radii of two circular coils is 1:2. So according to question, what we have? We have the value of ratio of radii. Radii of two circular coils is 1:2. So we may also write here as R1 is to R2 equal 1:2, where R1 is the radii of the first coil, R2 is the radii of second coil, right? The ratio of the currents in the respective coils such that the same magnetic moments is produced at the center of each coil. Like here, one more information is given to us, same magnetic moment. And usually we used to represent this magnetic moment by capital M. So it will be M1 equal M2, right? And what is our aim is to calculate? Our aim is to calculate I1 is to I2, right? Now, what is the formula, basic formula, direct formula of magnetic moment? M equal IA, where I is current and A is area. And here in this condition, we are using two circular coils having radii R1 and R2. And as it is known to everyone, like area of circle is what? Pi r square. So we are going to write this as I into pi r square. Now I am going to use this formula on the given data that is given in the question, that is M1 equal M2, right? So from here what I can write? I can easily write here I1 into pi R1 square equal I2 into pi R2 square. Now we can cancel and out these pi, right? And what is our aim? Our aim is to calculate I1 is to I2, right? Therefore, what we can write here? I1 by I2 equal R2 by R1 whole square, right? And according to question, which value is given to us? It is R1 is to R2. It is R1 is to R2. And what we have to put? We have to put R2 is to R1. So definitely it is going to be what? 2 by 1 whole square. And finally what you are going to find? It will be 4 is to 1. This will be the ratio of I1 is to I2. Hope it is clear to everyone. And the same thing you can see here in the option, that is option number 4 is the correct option, and the same thing is written there, that is option number 4 is the correct option. Hope it is clear to everyone. Question number 3, that is the current in an inductor of self-inductance 4 Henry, for self-inductance 4 Henry, that is capital L, the value of capital L is given to us, changes from 4 ampere to 2 ampere. That is initial current is what? 4 ampere and final current is what? 2 ampere. In 1 second, the EMF induced in the coil is. Like here, this question you can solve directly by using what? Formula. And which formula you have to use here? E equal minus of L di by dt. Since EMF equal minus of L di, it's better to write here delta I by delta t, right? Now I am going to put the respective values that is given in our question. At the place of minus it will remain minus. At the place of L I am going to put here 4. At the place of delta I, that is final minus initial. So final current is what? 2. Initial current is what? 4. And total time taken is what? 1. Right? So after solving this part, what you are going to find? You are going to find it will be minus 4 into minus 2. And after solving this, what you are going to find? It will be 8 volt. It will be 8 volt. That is given in our option number 3. And the same thing is written there. That is option number 3 is the correct option. Hope it is clear to everyone. Here is the question number 4. That is, an electromagnetic wave is moving along negative z direction, and at an instant of time at a point its electric field vector is 3 J cap volt per meter. The corresponding magnetic field at that point and instant will be. Here you have to consider the value of C, that is equal 3 into 10 to the power 8 meter per second. Now this is a completely direct formula based question, as well as one concept you have to use here. This question is from EM waves, that is electromagnetic waves, right? So the very first thing is to calculate the magnitude, like which option will be correct, right, according to magnitude. As it is known to everyone, like since E naught equal B naught into C, if I am considering only magnitude, therefore what we can write here, therefore our aim is to calculate B, magnitude of B naught, so it will be E naught by C, and according to question the value of electric field is what, 3. Here I am only considering what, magnitude, not direction, so it will be 3, and the value of C is what, 3 into 10 to the power 8 meter per second. Now this 3 will cancel the another 3, and here what you are going to get, you are going to get 10 to the power minus 8. But according to question, all the datas, all the options are in nano Tesla, that is 10 to the power minus 9 Tesla. So here in this situation, in next step, what I am going to do, I am going to multiply and divide by 10, so that what you are going to find, it will be 10 to the power minus 9, right? So from here what you can say, from here option number 2 will be the wrong option. At the same time option number 3 will also be the wrong option. Now the confusion is which option will be correct in between option number 1 and option number 4, right? So in order to understand, in order to determine the direction of magnetic field, you have to use the concept of right hand thumb rule, and you have to use the concept that is, in case of EM waves, the direction of the propagation of wave and the direction of magnetic field, at the same time the direction of electric field will be mutually perpendicular to each other, right? So here in this situation, according to question, what you have to focus, like the electromagnetic wave is moving along negative z axis. So I am going to represent here z axis, negative z axis by cross, right? At the same time, the direction of electric field is along what, positive y axis. So this is the direction of electric field. Now our aim is to calculate the direction of what, magnetic field, so that we can pick out which option will be correct in between option number 1 and option number 4, right? So here what is, in which direction the wave is propagating? Wave is propagating along negative of z axis, that means inside the board, right? At the same time here the direction of electric field is what, along j axis, positive of y axis. So in which direction your finger will move? Obviously along positive of x axis, right? So definitely what you are going to write here, the direction of magnetic field will be this one, the direction of magnetic field will be this one. You have to use your right hand, this is right hand thumb rule, like the wave is propagating along the z axis and the finger is along the y axis, that is along the direction of electric field. Therefore definitely this curling finger is along which axis? Is along x axis, right? So definitely your answer will be what? Will be I cap Tesla, right? Here in next step I am going to write it in more simplified format. So in next step what you are going to find? You are going to find the final value, that is B vector. Here I can't write I cap because here I am only writing what, magnitude. So finally in next step I am going to write here it in vector format, that is 10 nano Tesla, and direction will be along which axis? Along positive x axis. At the place of this 10 to the power minus 9, at the place of 10 to the power minus 9 I have written here nano, and Tesla is the unit of magnetic field, and here I cap is indicating what? Direction of magnetic field. I cap into I cap nano Tesla. Hope it is clear to everyone. And from here what you can say, option number 4 will be the correct option, and the same thing is written there, that is option number 4 is the correct option. Hope it is clear to everyone. So here we are going to discuss question number 5, that is two amplifiers of voltage gain 20 each are cascaded in series. If 0.01 volt AC input signal is applied across the first amplifier, the output AC signal of the second amplifier in volt is, right? So according to question we have some information, that is this is nothing but what? Voltage gain. Usually we used to represent it by AV, right? And are cascaded in series. So AV net is equal to, here what you are going to find, net AV equal, let's call this as AV1, and here this is also equal to AV2, right? So in next step what you are going to write, AV or net voltage gain equal AV1 into AV2, that will be equal to 20 into 20. So finally what you are going to get, here you are going to get 400. Is it clear to everyone? Good. Now in next step, as it is known to everyone, since formula of voltage gain equal V output by V input, right? And according to question, the value of if 0.01 volt AC input signal is applied, therefore V output will be equal to AV into V in, where AV, value of AV is what? 400, that we have calculated just now, and the value of V in is what? 1 by 100, right? We can also write this 0.01 as 1 by 100. So after solving this part, what you are going to get? You are going to get 4 as final answer. And the same thing you can see here in the option number 1. And the same thing is written there, that is option number 1 is the correct option. Hope it is clear to everyone. Now here is the question number 6. Let's read what is written here in the question. A linearly polarized monochromatic light of intensity 10 lumen. This is the value of intensity. 10 lumen is incident on a plane polarizer. The angle between the direction of polarization of the light and that of the polarizer such that the intensity of output light is 2.5 lumen. Like here this is the value of final output, or this is the value of final output intensity that we are getting through the polarizer, right? Here I am going to use the formula, that is I equal I naught cos square theta, and here in this condition we have to calculate the value of theta. That is already given, that is already mentioned here in the question. A linearly polarized monochromatic light of intensity 10 lumen is incident on a polarizer. The angle between the direction of polarization of the light and that of the polarizer such that the intensity, means you have to make such an angle so that you are going to find the final intensity, or the intensity in the output will be equal to what? 2.5 lumens, right? So in next step what I can write here? I can easily write here cos square theta will be equal to I by I naught, right? And here the value of I is what? 2.5, and the value of I naught is what? 10. So we can also write it as 25 by 100. After solving this part, what you are going to get? You are going to get it is 1 by 4. But what is our aim? Our aim is to calculate the value of theta, right? Therefore, what we can write here? Cos theta will be equal to 1 by 2. Therefore, value of theta, at which value of cos theta we used to get what? 1 by 2 at 60 degree. So therefore, the value of theta will be equal to 60 degree. That is already given in our option number 4, and the same thing is written there, that is option number 4 is the correct option. Hope it is clear to everyone. Here is the question number 7. Let's read what is written here. A stone is thrown vertically downward with a with an initial velocity of 40 meter per second from the top of a building. It reaches the ground with velocity 60 meter per second. Then the height of the building is. Like here in this question, what is written? A stone is thrown vertically downward with an initial velocity of 40 meter per second. Like let us suppose this is our building of height h, right? H equal, h we have to calculate the height of the building. A stone is thrown vertically downward. Here is the stone. And here in this condition u equal 40. And here what you are going to find? A equal g. That is equal, let's call here 10 meter per second square, right? Now, here the final velocity is what? Final velocity V is 60 meter per second. Now, which formula I am going to use here? V square minus U square equal 2GH, right? And here in this condition, the value of V is what? 60. So, it will be 3600. And the value of U square will be what? 40 square. That means 1600. And here at the place of 2, I am going to write here 2. At the place of G, I am going to write here G. And at the place of H, I am going to write here H. Now, in next step, what I am going to do? I am going to subtract it, right? So, here it will be 0, 0, 6 minus 6, 0. And 3 minus 1, 2. And then it will be 20H, right? Now, this 0 will cancel the another 0. And finally, what you are, this 2 will cancel this part. And finally, what you are going to find? You are going to find the value of H equal 100 meter. And the same thing you can see here in the option number 3. And the same thing is written there. That is option number 3 is the correct option. Hope it is clear to everyone. So here is the question number 8. That is a concave lens of focal length 25 centimeter. First of all, we have to draw a concave lens of focal length 25 centimeter. Let's call this as F1, that is equal to minus of 25 centimeter, because this is a concave lens. Now, what I am going to do? I am going to draw one more lens here, that is F2. Let's call this as F2, and its value is what? 40 centimeter. This is also given in the question. And this is the third lens here. And this value is also what? F2, because the focal length of the two convex lenses are same. So, here it will be 40 centimeter, right? Now, in next step, what we have to do? We have to combine all of them and we have to find out what the value of net focal length, right? And then at the end, what is our aim? Our aim is to calculate net power, right? So, here in this condition, as it is known to everyone, since P equal 1 by F net in meter, right? And 1 by F net. 1 by net focal length equal 1 by F1 plus 1 by F1 plus 1 by F2 plus 1 by F. Here in this condition, it will be, it is a general formula as it is known to everyone, since this is the general formula. Therefore, for this condition 1 by F net equal, the value of F1 is minus 1 by 25, right? At the same time, the value of F2, the value of F2 is what? 1 by plus 1 by 40. And here this at the place of F3, again I am going to write here F2. Why? Because here the focal length of the third lens is also equal to F2, that is equals to 40 centimeter. So, again I am going to write here 1 by 40. So, in next step, what I can do? I can write, after eliminating this part, I can write here 2 by 40. Now, in next step, what I am going to do? I am going to make common. I am going to take common 5 from the denominator. So, it will be 1 by F net. 1 by F net equal 1 by 5 into minus 1 by 5 plus 2 by 8, right? And after solving this part, it will be 1 by 4. So in next step, what I can write here, 1 by 5 into 5 4s are 20, and then it will be minus 4 plus 5. So after solving this part, what you are going to get? You are going to get, it will be minus 4 plus 5 will be plus 1, and it will be 1 by 100, right? But our aim is to calculate 1 by 100, right? But our aim is to calculate what? Power. And as it is known to everyone, as I said to everyone, what? Power equal 1 by F net, where F should be in meter, right? So in next step, what I am going to write here? P power equal power equal 1 by F net. That is, here I am going to convert, this was in centimeter, right? So here in this condition, I am, after converting this centimeter into meter, it will be 100 by 100, right? So after solving this part, what you are going to get? You are going to get 1 diopter. That is given in our option number 2. And the same thing is written there. That is, option number 2 is the correct option. Hope it is clear to everyone. Now here is the next question, that is question number 9. A network of resistors is connected across a 10 volt battery with internal resistance of 1 ohm. It should be ohm. 1 ohm as shown in the circuit diagram. The equivalent resistance of the circuit is, right? So here what is our aim? Our aim is to calculate equivalent resistance. Here it is written, equivalent resistance of the circuit, right? So as this, in this situation, you can see these two resistors are in parallel and these two resistors are also in parallel. So here in this condition, the equivalent of this part will be 2 into 4 divided by 2 plus 4, that is equal to 6. So it will be 4 by 3. And after solving this part, again you are going to get, it will be 4 by 3. Now as you can see, this 4 by 3 is in series with this 2 ohm, and again this 2 ohm is in series with this 4 by 3, and finally this complete this region is in series with what? 1 ohm, right? So here in next step, what I am going to do? I am going to write the formula, that is R equivalent in case of series equal R1 plus R2 plus R3. As it is known to everyone, this formula plus R4 and dot 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 so on. So by using this formula, what you can say here, you can also write here like 4 by 3 plus 2, 4 by 3 plus 2 plus 4 by 3 plus 1. So in next step, it will be 8 by 3 plus 3. So after solving this part, it will be 3 3s are 9 and 9 and 8 17. Then it will be 17 by 3 ohm. And the same thing you can see here in the option number 4. That is, option number 4 will be the correct option. And the same thing is written there. That is, option number 4 is the correct option. Hope it is clear to everyone. Now here is the next question, that is question number 10. So the correct statement about the variation of viscosity of fluid with increase in temperature. Like here, what you have to mark, you have to write the correct statement about the variation of viscosity of fluid. The main thing that you have to focus here is viscosity of fluid with increase of temperature. And as it is known to everyone, like in case of fluid, viscosity of liquid decreases with increase of temperature. At the same time, viscosity of gases increases with increase of temperature. But here, let's read what is written here. Viscosity of both liquid and gases increases. What you have to do? You have to increase the temperature. Temperature is increasing, and what I said, viscosity, that is eta. Eta of liquid decrease with increase of temperature. At the same time, eta of gas increase with increase of temperature. This is the concept, right? So viscosity of both liquid and gas increase. This will be the wrong option. Now option 2, viscosity of liquid increases. Viscosity of liquid is decreasing. Viscosity of liquid decreases. This is the correct option. Viscosity of gas decrease. This is wrong option. So from here, what we can say? We can say like option number 3 is the correct option, and the same thing is written there. That is, option number 3 is the correct option. Hope it is clear to everyone. Now here is the next question, that is question number 11. Let L1 and L2 be the orbital angular momentum of an electron in the first and second excited states of hydrogen atom. The thing that you have to focus here is first and second excited state of hydrogen atom respectively. According to the Bohr's model, the ratio of L1 is to L2 is, right? So here in this condition, as it is known to everyone, like what is written here, let L1 and L2 be the orbital angular momentum of an electron in first and second excited state. So the very first thing is, what is the formula of orbital angular momentum? Since L equal NH by 2 pi, where H is a constant, Planck's constant, 2 pi is also constant. Therefore, what you can write here, L is directly proportional to N. N is number of or nth orbital, right? Now, here you have to understand this statement. Momentum of an electron in the first excited and second excited. First excited means it is talking about second orbital, right? It is after exciting from the first orbital, where the electron will go, it will go in the second orbital, right? At the same time, second excited state means what? Third orbital, right? So here in this situation, what you can say here, according to this question, the value of N1 is 2, at the same time the value of N2 is 3, right? And here, as I have already written, like orbital angular momentum is directly proportional to nth orbital. Therefore, what you can write here, your aim is to calculate the value of L1 is to L2. So it will be L1 by L2 equal N1 by N2, that will be equal to 2 by 3. And the same thing you can see here in the option number 3. So option number 3 will be the correct option, and the same thing is written there, that is option number 3 is the correct option. Hope it is clear to everyone. Now here is the next question, that is question number 12. During simple harmonic motion of a body, the energy at the extreme position is Now you tell me, what should be the energy at extreme position? First thing that I want to ask you, what should be the velocity? What should be the velocity of the bob at extreme position? At this position, let's call this is extreme position. How we use to decide this is an extreme position? Because here at this position, the velocity will become equal to 0 meter per second, right? So if velocity equals 0 meter per second, therefore definitely kinetic energy will be equal to 0, right? Now in next step, or it's better to write here only 0. Velocity at extreme position is 0. Therefore, kinetic energy at extreme position is also 0, and as it is known to everyone, energy always remains conserved in a system, right? So here in this situation, potential energy will be maximum. Potential energy will be maximum, and the same thing is given here in the option, that is always 0. No, it is wrong option. Purely kinetic. No, it is also wrong option. Purely potential. Yes, it is correct option. Both kinetic and potential. No, here we can't find kinetic energy because at extreme position velocity is 0. So it will also be a wrong option. So can you see, like just by going through our module, you can solve many of the question directly even on your fingertips. Like we have solved many of the problem based on such kind of pendulum, right? And many of the time I said, we discussed already in the classroom, like at this position, here this position is named as mean position, this position is named as extreme position. At extreme position, velocity of the bob will become equal to 0, as a result of which kinetic energy of the bob will also be equal to 0, and energy remains conserved in this isolated system. So finally potential energy is maximum at extreme position. So can you see, like just by using the concepts given in our module, you can solve these questions without wasting a lot of time, right? Or you may say, like you can solve these questions in few seconds, right? And the same thing is written there, that is option number 3 is the correct option. Hope it is clear to everyone. Question 13. Though the question seems lengthy, but it is very easy. Like if you have attended our class This was the basic of FBD, free body diagram, in chapter NLM, that is Newton's laws of motion, right? So let's read what is written here. When a body of mass m just begins to slide as shown, match list 1 with list 2. And here is the list 1 and here is the list 2. So let's start matching. Here P is representing, if I am going to make the way, if I am going to take this P first. So here this P is representing, this S is nothing but what? Weight, that is equal mg. So this P is representing mg sine theta. At the same time, this part will be mg cos theta. You have already studied in our class, right? So from here what we can say, P is nothing but what? Mg sine theta. It will be here. Then Q is normal. Q is normal. Why? Because this Q is perpendicular to the surface, right? Then S is weight. We have already considered here S as weight, right? Then obviously R will be friction force, right? Now let's start matching from this option. So here the first point, that is A is related with what? 2. So from here what we can say, option 1 and 2 is the wrong option. Then A is related with 2 in option 3 and 4. Then B is related with what? 3. But here B is related with 3 and in option 4 B is related with what? 1. So definitely our option number 4 will be the wrong option and option number 3 will be the correct option. And the same thing is written there, that is option number 3 is the correct option. Hope it is clear to everyone. Here we are going to discuss question number 14, that is 12 point charges, each of charge q coulomb is placed at the circumference of a circle of radius small r. So I am going to draw the respective diagram. This is a circle having radius small r with equal angular spacing. If one of the charge is removed, the net electric field at the center of the circle is. Like in the initial condition, what we have to do, we have to arrange 12 charges equally spaced. So here I am going to do the same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Now, in this condition, as it is known to everyone, electric field is a which quantity? Scalar or vector? Definitely vector quantity. So initially what we are going to find, electric field generated by the first charge, that is here, right, will be equal and opposite to the electric field generated by the 8th charge. Now electric field generated by the second charge will be equal and opposite to the 9th one. Here again you are going to find the same. Here again you are going to find the same. Here again you are going to find the same. As a result of which electric field at the center will be equal to 0 because here at the end what you are going to find, the net is equal to 0 at the center. But here in next situation, what is given in the question, you have to just remove any one of the charge. In this situation what you are going to find, you are going to find such kind of arrangement. This will be the value of R. Now here let's Q1, this is another charge, 1, 2, 3, here it is, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and one more 11, right? Now in this condition what you are going to find electric, and again I am going to name them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because we removed one charge, right? So here as it is known to everyone, electric field is a vector quantity. So again electric field produced by the charge placed at position 1 is equal to charge placed at position 7. Then this charge at 6 will cancel the electric field produced by 11. Charge at 5 will cancel the electric field produced by this 10, right? This is 10, not 16. So similarly, this electric field produced by the third charge will be cancelled by the 8th one. Electric field produced by the second charge will be cancelled by the electric field produced which is placed at 8th position. So here in this condition, if you can focus, only this charge will be responsible for the generation of electric field at the center, right? Or you may say only this charge will be responsible for the generation of net electric field at the center, right? So here what you will write, E equals, since E equal KQ by R square. So what will be the final formula? It will be 1 by 4 pi epsilon naught Q by R square. And the same thing you can see here in the option number 3. So option number 3 will be the correct option, and the same thing is written there, that is option number 3 is the correct option. Hope it is clear to everyone. Now coming to next question, that is question number 15. A block of mass m is moving with initial velocity u towards a stationary spring of stiffness constant k, that is a spring constant is given to us, that is k, attached to the wall as shown in the figure. Maximum compression of the spring is. So here in this figure what you can see, as it is known to everyone, here we are going to use which concept? Law of conservation of energy. Initially this block of mass m was moving with velocity u, and after collision, here it is already given to us like the spring constant or stiffness constant is what? K. So the energy imparted by this block on this spring will be same as the energy stored in the spring. So finally what we are going to use here? Here we are going to use the formula of kinetic energy, that is equals to half mu square, and energy stored in the spring, that is equal to half k x square. Now this half will cancel the another half, and finally what is our aim? Our aim is to calculate maximum compression. So here x will be equal to u root m by k, and the same thing you can see here, it is written in the option number 4. Hope it is clear to everyone, and the same thing is written there also, that is option number 4 is the correct option. Now here we are going to discuss question number 16 based on logic gates, right? So here you can also see we have some logic gates, right? So in this situation, the output of the logic circuit shown is equivalent to a or an, like you can't judge the answer by looking at the options, right? So here in this situation what you are going to find, as this is NOR gate, right? This is also NOR gate. So what you are going to find here, if I am going to draw the diagram again, here in this situation this is a NOR gate and this is again a NOR gate, right? And this will be the final output. So here this is A and this is B. So definitely it will be A plus B bar, because OR gate is what? A plus B, and as it is NOR gate, so it will be A plus B bar, right? So here in this situation what you are going to find, it will be A plus B bar here and A plus B bar here, right? So here at this will be Y, right? So here in this situation what you are going to find, Y will be equal to A plus B bar plus A plus B bar whole bar. Is it clear to everyone? Good. Now I am going to use De Morgan's theorem. By using De Morgan's theorem, what I can write here, A plus B bar over bar dot, because I am breaking this above bar, right? So here in this situation again A plus B bar whole bar, right? Now in next step what we can write here, we can easily write it as A plus B dot A plus B, right? And now in next step what we are going to find, it will be A plus B will be the right answer, and this is nothing but what? OR gate. OR gate. Let's check whether it is given in the option. Yes, it is already given in the option, that is option number 4 will be the correct option, and the same thing is written there, that is option number 4 is the correct option. Hope it is clear to everyone. So here is the question number 17, that is the plot of current I flowing through a conductor versus the applied voltage V across the ends of a conductor is. Like here it is already mentioned to us, the plot of current I flowing through a conductor versus applied voltage V. We have to draw what relation? We have to draw the graph on VI. Here along x-axis what we have? Along x-axis we have voltage and along y-axis we have current. Now here we have to use conductor, and conductors obeys Ohm's law, and according to Ohm's law V is directly proportional to I. So what you are going to get? You are going to get a linear graph passing through the origin. So here option number 1 wrong, 2 wrong, 3 wrong, option number 4 will be the correct option, and the same thing is written there, that is option number 4 is the correct option. Hope it is clear to everyone. Now here is the question number 18. Let's read what is written here. The value of resistance for the color code of the given resistor is. This is a direct question that you can solve by using a table given in our module also. So here is the table. Like you have already heard B.B. Roy, Great Britain has very good wife, right? So here we are going to use the same. That is here orange. You have to write here the sequence is given to us for the first digit, for the second digit, for the multiplier and for the tolerance, right? So for the first line it is orange. Orange, for orange what you have to write? Here you have to write 3. For the second line it is blue. So here is the blue. So it will be 6. For multiplier, multiplier is yellow. So here is the multiplier. Then fourth one is gold, that is tolerance. And here is the gold, that is plus minus 5%, right? Now I am going to write the proper value of resistance. So by using this, what I can write here? 3 into 6 into 10 to the power 4, right? And then what I have to write? I have to write plus minus 5%. But here in our option it is not mentioned like this, right? So what you have to do? You have to convert it. You have to calculate 5% of 36 into 10 to the power 4. So it will be 5% of 36 into 10 to the power 4. So it will be what? 2. After solving this part, what you are going to get? You are going to get this value, and finally it will be 180 into 10 to the power 2, and you can also write it as 18 into 10 to the power 3, right? Now the final answer will be what? 360 into 10 to the power 3 plus minus 18 into 10 to the power 3 ohm. This will be the final value of resistance. Now as in our question option, the values are given in kilo ohm. So what I am going to do in next step, it will be 360 plus minus 18 kilo ohm. Let's match the option. Here it is 470. Here it is, the 360 is okay, but here it is 36. So it will be wrong. Option number 3 is the correct option, and option number 4 will be the wrong option. And the same thing is written there. That is option number 3 is the correct option. Hope it is clear to everyone. Now here is the next question, that is question number 19. An inductor coil of self-inductance 10 Henry. Self-inductance 10 Henry carries a current of 1 ampere. The value of current is also given to us. The magnetic field energy is stored in the coil. Like as it is known to everyone, E equal energy equal half L I square. This is a very simple formula that you might have used many of the time while solving the question, right? So just use this 1 by 2 into 10 into 1, right? So after solving this part, it will be 5 joule. And the same thing, it is option 1 is wrong, 2 is wrong, 3 is correct, and 4 is wrong. And the same thing is written there, that is option number 3 is the correct option. Hope it is clear to everyone. Now here is the next question, that is question number 20. the dimensions of mutual inductance M are. As it is known to everyone, since in this question our aim is to calculate what? Dimensional formula. So for that we need any of the relation having what? Any of the formula or equation having what? Mutual inductance. Since E equal M di, E equal minus M di by dt, right? Now from here what we can write here? Therefore M equal EMF, that is E into E divided by, I am not considering in the next step minus sign because our aim is to calculate only what? Dimensional formula. So it will be di by dt, right? And we can also write this E as it is known to everyone, and V equal, or it's better to write here E equal W by Q, right? So from here what we can say? We can say this value, that is at the E, I am going to write here W, and at the place of di, it's better to pick only dimensional formula only, right? So from next step what I am going to write? Here I am writing only di by dt, and then here it will be Q also. Now in next step I am going to write the proper dimensional formula for what? Mutual inductance. So here M under the square bracket it will be M L T to the power M L square T to the power minus 2. This is the dimensional formula of work, or you may say energy also. Here the dimensional formula of current is what? Ampere. Again dq by dt. dq by dt, or here q by t will give you the dimensional formula A, right? So finally what you are going to find? You are going to find the final answer, that is M L square T to the power minus 2 A to the power minus 2, right? Let's check whether it is given. M L square, this is wrong. M L square T to the power minus 2 A to the power minus 2, this is also wrong. This is also wrong. M L square T to the power minus 2 A to the power minus 2. So M square, this is also wrong, right? So from here what you can say? Option number 3 is the correct option, and the same thing is written there. Option number 3 is the correct option. Hope it is clear to everyone.
So now we will solve question number 21. So the question is saying that a strong magnetic field is applied along the direction of velocity of an electron. The electron would move along. So that's a very easy question and exactly the question from our module. Okay. So we know that force on a charged particle due to magnetic field is nothing but F is equal to Q V cross B. Okay, and we can also open the cross product as Q into VB sine theta, where this theta is the angle between velocity and magnetic field. This V is velocity, B is magnetic field. In the question it's clearly given that magnetic field is applied along the direction of velocity. That means the angle between velocity and magnetic field's direction is 0, right? So if the angle is 0, then sine theta will be 0, and hence force acting on that charged particle, which is electron in this question, will be 0. That means no force is acting on that charged particle, so the charged particle will continue to move in its original path. Okay, so the electron would move along the original path. I hope you guys got it. Now we will move on to question number 22. So the question is saying, in a photoelectric experiment, blue light is capable of ejecting a photoelectron from a specific metal, while green light is not able to eject a photoelectron. Ejection of photoelectrons is also possible using light of which color? You have to choose from the options like which color can eject photoelectrons from that metal, given that green light is not capable of ejecting photoelectrons and blue light is capable. So we know that VIBG YOR, VIBGYOR. This is the order of wavelength, or I can say energy also. If I will move from left to right, then wavelength will increase, and if we will move from left to right, what about energy? Energy will decrease, right? So given that blue light is able to eject photoelectron, but green light is not able to eject. That means we know that green light's wavelength is higher as compared to that of blue light. That means blue light and green light, the threshold wavelength for that photoelectric metal lies between the wavelength of blue and green. So if blue is able to eject photoelectrons, that means lights, or I can say waves which have wavelength less as compared to that of blue light will be able to eject the photoelectrons, right? So I can say that indigo as well as violet can eject photoelectrons from that metal. Now let's check in the options. Red is given, violet, orange and yellow. So only this violet and indigo can eject photoelectrons, and in the option I can see option number 2 is saying violet. So option number 2 will be the correct answer for this question. Now we will solve question number 23. So the question is saying that when the circular scale of a screw gauge completes 2 rotations, it covers 1 mm over the pitch scale. The total number of the circular scale divisions is 50. So the least count of the screw gauge in meters is. Again, that's a very easy question, and the question is from our module also. Okay, so we have to find the least count, and we know that least count is nothing but pitch divided by number of divisions on the circular scale, and it's given in the question very clearly that total number of circular scale division is 50. It's given in the question that total number of circular scale division is 50. So least count will be nothing but pitch divided by 50. Now what about pitch? How we will calculate the pitch? Pitch is nothing but the distance, the linear distance moved by the linear scale on one complete rotation of the circular scale. So it's given in the question that the circular scale of a screw gauge complete 2 rotation and it covers 1 mm over the pitch scale. So it's given to me that on 2 rotations, distance moved by the linear scale is 1 mm. So on 1 rotation, the distance moved on the linear scale will be nothing but 1 by 2 mm. That's basic unitary method, right? So pitch is nothing but 1 by 2 mm. That's nothing but the value of pitch. So pitch is nothing but 1 by 2 mm, and 1 mm is nothing but 10 raised to the power minus 3 meters, as we have to give the answer in meters. Okay, so divided by 50. So this will be nothing but 10 raised to the power minus 3 divided by 50 into 2, which is 100. So it will be nothing but 10 raised to the power minus 5 meters. So that's the least value that this scale can count. Okay, now let's check the options. 10 raised to the power minus 5 is given in option number 1. Okay, so option number 1 will be the correct answer to this question. I hope you guys got it. Now let's move on to question number 24. So the question 24 is saying that a beam of light is incident vertically on a glass slab of thickness 1 centimeter and refractive index 1.5. The fraction A is reflected from the front surface while another fraction B enters the slab and emerges after reflection from the back surface. Time delay between them is. So basically the question is saying something like this, that we have a glass slab like this, okay, and light is incident on this glass slab vertically. That means in this way. So this light has been split into 2 fractions, A and B. So fraction A is reflected from the front surface. Fraction A is reflected from the front surface. So fraction A has been reflected from this surface, okay, like this. And fraction B enters the slab and emerges after reflection from the back surface. What about fraction B? Fraction B is entering the glass slab, it is going down and it is reflecting from the back surface. That's the back surface, okay. So it is reflecting from this one, again going in the upward direction, then it is emerging out. So we have to find the time delay between fraction A and fraction B. So basically fraction A just reflected from the front surface, fraction B covered entire distance till the back surface, then again covered the whole distance in the upward direction and then it emerged out. So basically the time delay will equal to the time taken by fraction B to cover this distance inside the slab, isn't it? So we will just calculate the time taken by that fraction B in covering this distance of slab twice. Like it came distance D downward and distance D upward again in order to go up in the upward direction, right? So how can I calculate that time? So time is nothing but distance upon speed, isn't it? How much is the distance? That means the thickness of the slab, and it's given to you in the question that thickness of the slab is 1 centimeter. So the distance will be nothing but 2 into this thickness, because it's going down and up as well. So the distance is 2 into d, and d is 1 centimeter. That means 10 raised to the power minus 2 meters. What about speed? See, this is a beam of light. So its speed is nothing but the speed of light, which is 3 into 10 raised to the power 8. But it is not in the vacuum. 3 into 10 raised to the power 8 is the speed of light in vacuum. The light is traveling inside a glass slab. So its speed will become, V will be equal to C by mu. Okay, C is nothing but 3 into 10 raised to the power 8 meter per second divided by mu, which is the refractive index of glass, which is 1.5. So it will be nothing but 2 into 10 raised to the power 8. So just divide it with the speed, which is 2 into 10 raised to the power 8. So this 2 will just get cancelled out. 10 raised to the power 8 will go in the numerator as 10 raised to the power minus 8. 10 raised to the power minus 2 is already there. So time taken, or I can say the time delay, will be nothing but 10 raised to the power minus 10 seconds. And that's the final answer. Now let's check in the options. I can see that 10 raised to the power minus 10 second is given to you in option number 4. So option number 4 will be the correct answer. I hope you guys got it. Now let's move on to question number 25, which is again a very interesting question. So this is based on assertion and reason type question. Okay, so we'll first read the assertion, what it is trying to say, that a standing bus suddenly accelerates if there were no friction between the feet of a passenger and the floor of the bus. The passenger would move back. Let's read out the reason. That in the absence of friction, the floor of the bus would slip forward under the feet of the passenger. The main thing here is the absence of friction. Okay, so there is a person standing inside a bus. Okay, just suppose this is the floor of the bus and these are the legs of that person which is standing inside the bus. Okay, now what happens? This bus suddenly accelerates. So in general, what happens is, when we travel in the bus, what happens is there is friction between our feet and the floor of the bus. So when the bus accelerates suddenly, the friction force between the floor of the bus and our feet pushes our feet in the forward direction, right? But there is absence of friction. So what will happen, like if these are the legs of that person and this is the bus floor, so when the bus will start accelerating, since there is no friction, so the bus floor will move in the forward direction and the person will be standing at the same position. Just think it, like when you are standing like this and if this platform starts moving, then the only force which is responsible for you to move in the forward direction is friction. But if friction is not there, there is no force which will drive you in the direction of the motion of the bus. Okay, so if there is no friction, so the floor of the bus will just start moving in the forward direction and you will be at the same position. Okay, but in general, what comes to your mind after seeing that assertion, that a standing bus suddenly accelerates and if there is no friction between the feet of a passenger and the floor of the bus, the passenger would move back. Yeah, the statement seems true in the first go, but the passenger would move back in the bus frame, not in the ground frame. The frame of reference is not mentioned in the assertion, and we know that when there is no frame of reference mentioned, we take ground as a reference frame. Okay, so yeah, according to the person, just suppose if there is some person sitting here and we are standing just beside that person, so according to that person, yeah, when the bus will start moving forward, we'll be at the same position and that bus will move in the forward direction. So according to that person, we are moving back. But according to the observer, which is observing from ground frame, the person is standing here, the bus has started moving, and since there is no friction, so this person's leg will feel no force in the horizontal direction which will move that person. Okay, so there is no force, so that person will not move and the person will be standing at the same position, just the bus will move, and according to the ground frame, that person will be at the same position. Okay, that means this assertion is wrong. That means this assertion is false. Why so? Yeah, the passenger would move back but in the frame of bus. And since no frame has been mentioned, so we will take ground as a reference frame. That's why assertion is false. Okay, let's check the reason also, that in the absence of friction, the floor of the bus would slip forward under the feet of the passenger. Yeah, exactly, that's what we have discussed. that in the absence of friction, the floor of the bus would just slip forward under the feet of the passenger. The passenger will be at the same position. So yeah, reason is correct, but assertion is false. So in the options, it's given in option number 1 that A is false, but R is true. So option number 1 will be the correct answer for this question. I hope you guys got it. That's great. Now, let's move on to question number 26, which is again a very easy question. Okay, that a gas undergoes an isothermal process. The specific heat capacity of the gas in the process is. Again, that's a question from our module. It's a solved example in the module itself. Okay, so it's given in the question that I have to find the specific heat capacity. So we know that delta Q is nothing but ms delta T. Okay, we have to find the specific heat capacity. So this S will be nothing but delta Q divided by m delta T, right? And given that process is isothermal. What do we mean by isothermal process? The process in which temperature remains constant. That means the value of this delta T will be 0 in isothermal process, and if this delta T is 0, then this S will be infinite, right? So option number 4 will be the correct answer for this question. Now let's move on to question number 27. And the question is again damn easy, that a fluid of density rho, okay, a fluid of density rho is flowing in a pipe of varying cross-sectional area as shown in the figure. The Bernoulli's equation for the motion becomes. What do we understand by Bernoulli's equation? What's Bernoulli's equation? Bernoulli's equation is nothing but pressure energy per unit volume plus kinetic energy per unit volume plus potential energy per unit volume remains constant for a fluid, right? So pressure energy is nothing but P into V. Pressure energy per unit volume is PV by V plus kinetic energy, that means half mv square per unit volume again. So let it be small v, okay, and this volume is capital V, plus potential energy, which is again mgh divided by volume, as we have to consider potential energy per unit volume. This will be constant. Okay, so I can see that this V will just get cancelled out. This is mass per unit volume, so it will be nothing but density. So this will be half rho V square. This V is velocity plus m by V, again mass per unit volume is again density gh. This will be constant. So rho plus P plus half rho V square plus rho gh will be constant is the Bernoulli's equation. So in these 4 options, I can see that this option number 4 is matching with our Bernoulli's equations. Option number 4 will be the correct answer for this question. I hope you guys got it. Now let's move on to question number 28. The question is saying that at some instant the number of radioactive atoms in a sample is n0, and after time t the number decreases to n. It is found that the graphical representation ln n versus t along the y and x axis respectively is a straight line. Then the slope of this line is. Again, that's a very easy question. We have to just identify the slope. Okay, we know the equation that n is nothing but n0 e raised to the power minus lambda t, where this n0 is the number of radioactive atoms in the sample and this n is the number of radioactive atoms present at time t. Okay, so if I will take log on both the sides, so this will be nothing but ln n, this will be equal to ln n0 e raised to the power minus lambda t. So we know the property that ln of m into n will be nothing but ln m plus ln n. Okay, so I can write it as nothing but ln n0 plus ln e raised to the power minus lambda t. Now this is ln e raised to the power minus lambda t, so this minus lambda t will come in the front and ln e will become 1. Okay, so I can write it as that it will be ln n will be equal to ln n0 minus lambda t into ln e, and value of ln e is nothing but 1. So that's our equation. That's our equation. And the graph was plotted between ln n versus t. Okay, so this ln n is our y and this t is our x. Okay, and this is the form of, this is the general equation for a straight line, that y equal to mx plus c. So the coefficient, or I can say the term which is along the x will be the slope. right? So the coefficient of t is minus lambda. So the slope for this case will be nothing but minus lambda, right? So let's check for the options. So minus lambda is shown to us in option number 1. So for this question, option number 1 will be the correct answer. I hope you guys got it. Now let's move on to question number 29. That a particle of mass 4 mkg at rest splits into two particles of mass m and 3m. The ratio of the kinetic energies of mass m and 3m would be. We just have to find the ratio of kinetic energies. Okay. We know that if a particle of mass 4m kg is at rest and it has splitted into two particles, that means there is no external force acting on that object, right? That means I can say the linear momentum will be conserved, isn't it? So I can say that if momentum is conserved and I have to find the ratio of kinetic energies, so I can write the kinetic energy in the form of momentum, that it will be nothing but p square by 2m. We know the relation between kinetic energy and momentum of a particle, right? This p is the momentum. And why we are using this relation that k equal to p square by 2m? Because we know that this momentum will be conserved. Why so? Because there is no external force acting in this case when this 4m kg mass is splitting, right? So the ratio ke1 by ke2 will be nothing but this p will be same for both the objects, right? Like the splitted particles are of mass m and 3m, so they will have the same momentum, right? And this 2 is also same for both of them, exactly, right? So this will be nothing but m2 by m1, since I can see kinetic energy is inversely proportional to mass according to this relation. Okay, so m2 is how much? M2 is 3m and m1 is how much? M. So this m will just get cancelled out, and the ratio of kinetic energies ke1 is to ke2 will be nothing but 3:1. And it's given to us in option number 4. And if you have some doubt that why both of them will have same momentum, then we can say that since momentum is conserved, so I can say that initial momentum will be equal to final momentum, right? So initial momentum was 0 as the 4m mass was at rest. As the 4m mass was at rest, so initial momentum will be 0. Final momentum will be of this m mass moving with v1 velocity, or I can write it as like this, that this will be nothing but momentum of mass m plus momentum of mass 3m. And if it is equals to 0, so in magnitude they will be equal to each other, that p of m will be equal to p of 3m in magnitude. That's why we have cancelled this p square and directly took the ratio of masses in order to calculate the ratio of kinetic energies. I hope this is very much clear to everybody, right? That's great. Now let's move on to question number 30, which is again a very easy question, and exactly this question is given in our module. Okay, so the question says that a hollow metal sphere of radius r is given plus q charge to its outer surface. Okay, the electric potential at a distance r by 3 from the center of the sphere will be. So since this is a metal sphere, that means it's a conducting sphere, and we know that inside a conductor the potential remains constant, the potential remains same, and if it's a hollow sphere, right, so the potential inside is constant and the value of that potential will be equal to the value of potential at the surface of the sphere, right? So whatever will be the value of potential at the surface will be the value of potential inside the whole sphere. Okay, so it's given to us that we have to find the electric potential at a distance r by 3 from the center. So that means if this is the sphere, if this is the sphere of radius r, I have to find the potential at a point which is at r by 3 distance. That means it's an inside point. It's an inside point. So the potential will be same throughout the sphere and it will be equal to the potential at the surface. So potential at the surface will be nothing but V will be equal to kq by r. Okay, and in the options this k is written as 1 upon 4 pi epsilon naught. So it will be nothing but 1 upon 4 pi epsilon naught q divided by r. Now let's check it in the options. It is 3q by 4 pi epsilon naught. So this is not the correct answer. This is kq by 3r. Again, that's the wrong one. 9r is there, so it's the wrong one. Kq by, okay. So option number 3 will be the correct answer for this question. I hope you guys got it.
Now, we are going to solve our next question, and that is question number 31. Rain is falling vertically downward with a speed of 35 meter per second. Wind starts blowing after some time with a speed of 12 meter per second in east to west direction. The direction in which a boy standing at a place should hold his umbrella is. Okay, let us see how to solve this question. This is the direction of rain, okay, which is vertically downward, and it is 35 meter per second. Okay, direction of wind is from east to west. Here it is east, west, north, and this is south. So from east to west, it means we can see in this direction. That is the direction of wind flow, and speed is 12 meter per second. Okay, so here we can see that resultant direction of rain, that would be this one, according to parallelogram rule. Okay, so this is 35 meter per second, this is 12 meter per second. So we can say with the vertical, rain is making an angle theta. Okay, and this theta can be find out very easily. Tan theta, that is perpendicular upon base. Perpendicular, if it is 12 meter per second, then we can say this is also 12 meter per second. Okay, so perpendicular is 12, base is 35. So 12 upon 35. So from here we would get theta, that is tan inverse 12 upon 35. And this is the angle between vertical and the resultant direction of rain. Okay, so in this direction, the boy should hold his umbrella. Okay, like this. Okay, I hope you got it. Now, let us take our next question. Here it is. Question number 32. Ratio of the moments of inertia of two spheres about their diameter and having same mass and their radii in the ratio 1:2. Okay, so here we are going to find out the ratio of moment of inertia. So as we know, I, for the solid sphere, we know 2 by 5 mr square, and for hollow sphere, moment of inertia with respect to its diametrical axis, that would be 2 by 3 mr square, that we know. Okay, now let it is IS solid and this is IH for hollow sphere. So IS1, IS2, that is of second sphere moment of inertia. So that would be 2 by 5 m r2 square. Let it is r1. Okay, and for hollow also we can say it would be 2 by 3 m r2 square, and it is r1 square, that is IH1, this is IH2. Okay, so ratio of IS1 and IS2, that would be 2 by 5 cancel out, m cancel out. Here also we can see that 2 by 3 m cancelled out. So from here we can see that ratio of moment of inertia, that would be r1 square upon r2 square. Okay, and here we can see r1 upon r2 whole square. r1 upon r2, that is 1:2. So 1 by 2 whole square, that is 1 by 4. Okay, so that would be the ratio of moment of inertia. So we can write it as 1:4. So third option is the right answer. Okay, similarly for hollow also we can say the same thing. Okay, I hope you got it. Now let us take our next question, and that is Question number 33. A string is wrapped along the rim of a wheel of moment of inertia 0.1 kilogram into meter square. Radius, that is 10 centimeter. If the string is now pulled by a force of 10 Newton, then the wheel starts to rotate about its axis from rest. Okay, the angular velocity of the wheel after 2 seconds would be. Let us see how to solve this question. Here we are going to find out angular velocity after 2 seconds. Okay, so as here we can see that force which is being applied, that is constant. Okay, and radius of that wheel, that is also constant. So we can say torque also would be constant, and if torque is constant, then angular acceleration also would be constant. Okay, so we can apply this formula. Omega is equal to omega naught plus alpha t. Okay, omega naught, that is 0. Why? Because it was started from rest. Okay, alpha we will see. T, time is 2 seconds. Okay, now we will find out alpha. As we know, tau is equal to I alpha. Okay, so from here tau, that would be r into f. Okay, side 90 would come, and that would be 1. That's why I am writing here r into f directly. I, and this is alpha. So alpha, that would be rf upon I. Value of r, that is 10 centimeter. So it would be 10 into 10 raised to minus 2 meter. Force, that is 10 Newton. Okay, value of I, moment of inertia, that is 0.1. 0.1. Okay, solving it, we would get alpha is equal to 10 radian per second square. Okay. Okay, so from here we will put value of alpha. So from here omega would come, alpha is 10, it is 2, so it would be 20 radian per second. That would be the answer. Okay, that would be the angular velocity of the wheel after 2 seconds. So third option is the right answer. Okay, I hope you got it. Now let us take our next question. Okay, now we are going to solve question number 34. Assuming the Earth to be a sphere of uniform density, its acceleration due to gravity acting on a body will change or not with all these factors. Let us see. First one, increases with increasing depth. As we know that z dash is equal to z, 1 minus d by r. Okay, so according to it, we will see that with depth, acceleration due to gravity would decrease. Okay, it will not increase. So it is wrong statement. Second one is independent of the mass of Earth. Okay, let us see. As we know, z, that is gm upon r square. Okay, and on the surface of Earth, z, that is gm upon capital R square, let it is g double dash. Okay, so here we can see that g is not independent of mass of Earth, so it is wrong statement. Third one is independent of the mass of the body. Let us see. Z dash, let it is gm upon r square, or it is g double dash. Okay, so from here also we can see that this g is not depending on the mass of the object. Okay, so it is independent of the mass of the body. So this is the correct statement. Fourth one is increases with increasing altitude. As we know, z dash, that is z 1 minus 2h upon r. It means with increasing altitude, z would decrease. Okay, so it is not right statement, but it is wrong statement. Okay, So we can see the third option is the correct answer. Okay. Question number 35. If lambda x, lambda I, lambda m and lambda gamma are the wavelengths of X-rays, infrared rays, microwaves and gamma rays respectively, then which relation is correct? Okay. This is an informational question. So for this question, you should learn what is the wavelength ranges of different EM waves. Okay. Let us see. First of all, microwave. That would have the largest wavelength among all these four. Okay. Then infrared, and then less than infrared, there would be X-rays, and finally gamma rays. That would have minimum wavelength among all these four. Okay. So in these options, we can see that the fourth one is the right option. Okay. So fourth option is the correct answer. Okay, now let us take our next question, and that is question number 36. The fraction of the original number of radioactive atoms that disintegrates, decays during the average lifetime of a radioactive substance will be. It means in this question we have to find out this ratio. N naught minus N decayed radioactive atoms divided by the initial number of radioactive atoms. Okay. So as we know, it would be N naught N, that is N naught e raised to minus lambda t divided by N naught. Okay. So from here we can take N naught common. It would be 1 minus e raised to minus lambda t upon 1. N naught cancelled out. Now, what is time? Time is average lifetime. Okay. It means tau average, and that is equal to 1 upon lambda. So we will put here 1 minus e raised to minus lambda, and it is 1 upon lambda. Lambda and lambda cancelled out. So it would be 1 minus e raised to minus 1. Solving it, we would get 1 minus 1 upon e. So that would be e minus 1 upon e. Okay, that would be the fraction, okay, or ratio. It means third option would be the right answer. Okay. Now let us take our next question, and that is question number 37. 3 capacitors, each of capacitance 0.3 microfarad, are connected in parallel. This combination is connected with the another capacitor of capacitance 0.1 microfarad in series. The equivalent capacitance of the combination would be. Okay, let us see. First one, second one, third one. These are connected in parallel, and the fourth one, that is connected in series. Okay, this is point A, this is point B. It means we are going to find out resultant capacitance between point A and B. Okay, this is of 0.3 microfarad. This is also of 0.3 microfarad, and this is also of 0.3 microfarad, and this one is of 0.1 microfarad. Okay, so these are in parallel. So we can say resultant of these three would be 3 times of 0.3, that would be 0.9 microfarad. Okay. Now this 0.9 microfarad is in series combination with this 0.1 microfarad. Okay. So C net, that would be C1 C2 upon C1 plus C2. Solving it, we would get C1 0.9, C2 0.1, C1 0.9, C2 0.1. Solving it, we would get C net. So finally, from here we would get C net, that is 0.09 microfarad. Okay, this would be 1. Okay, so from here we can see that option number 1 is the correct answer. Okay. Now let us take our next question, and that is question number 38. Given below are two statements. Statement 1. Magnetic field of a circular current loop at very far away point on the axial line varies with distance as like that of a magnetic dipole. Okay. Second statement, magnetic field due to a magnetic dipole varies inversely with the square of the distance from the center of the axial line. Okay, these are the two statements. Now, we will check which one is correct and which one is incorrect. Okay, so first one we will check. Okay, so this is the current carrying loop and this is a point P which is very far away from center of this loop. Okay, let it is R and this is X. And X is very, very larger than R. Okay, in that case we know magnetic field at this point that would be mu naught Ni upon 2 pi x cube into pi r square. This would be the formula, okay, for magnetic field at point P, which is very far away from this current carrying loop. Okay, so from here we can see that all these quantities are constant, mu naught Ni pi r square upon 2 pi. So from here we can see B is proportional to 1 upon x cube. Okay, 1 upon x cube. So let us see. Very far away point on the axial lines varies with distance as like that of magnetic dipole. Yes, for magnetic dipole also we know that magnetic field on the axial line that would be 2 mu naught upon 4 pi m upon r cube. Okay, that was the formula for magnetic dipole. Okay, so here also we can see B is proportional to 1 upon r raised to 3 and here also we can see B is proportional to 1 upon x raised to 3. It means both are varying with same variation of distance. Okay, so we can say that first statement is correct one. Now, second one, magnetic field due to a magnetic dipole varies inversely with the square of distance from the center of the axial lines. Square word is there, but as we have seen right now, B proportional to 1 upon r cube and this is for dipole on the axial line. Okay, so here it is r cube, not r square. Okay, so we can say that second statement is wrong. Okay, so we can say that statement 1 is correct and statement 2 is incorrect. So fourth option is the right answer. Now, let us see our next question and that is question number 39. Okay. Circuit represents a full wave bridge rectifier when switch S is open. When switch S is open, okay, then it is full wave rectifier. The output voltage VO pattern across RL, this is RL, when S is closed. Now, when S is closed, what would be the pattern of output voltage? Okay, let us see. First of all, initially this is positive and this is negative end. Okay, so current would try to come out from this end. Okay, now here we can see that this would be in reverse bias. Okay, for this orientation, it means we can see that current would not pass from this end, but current would take this path from here because it would be forward bias. It is reverse bias. It is also reverse bias. So current would not pass from this one and this one, but current would pass from here to here. Then finally it will take this path, and in this way circuit would be complete. Okay. So in this way there would be output on this RL. Okay. So let input is this one. Okay. So output that would be this one for first half. Okay. Now for the second half, this would be the positive end, this would be the negative end. Now, in this case, we will see that current will try to flow from this end, okay? And here we can see that in this case, this would act as ideal diode in forward bias, ideal diode in forward bias. Okay, so there will be no resistance of this one. That's why here we will see that current would not take this path because there is some resistance, but current would take this path. It means current will flow in this path and circuit would be completed. In this case, there would not be any output. There would not be any output on this RL. Okay, so this part would be absent. Again, when this part would be at positive and this would be at negative, then this would come as output. Okay, so here we can see that among all these fours, we can say fourth option would be the correct answer. Okay, that is the output voltage pattern. Okay, I hope you got it. Okay, now let us take our next question, and that is question number 40. When a particle with charge plus q is thrown with an initial velocity v towards another stationary charge plus q, it is repelled back after reaching the nearest distance r from plus q, the closest distance that it can reach if it is thrown with initial velocity 2v. Okay, let us see how to solve it. This is the small q charge and this is capital Q charge. Both are positive. Initially, this is given velocity v. Okay, so it would reach up to this distance, which is small r from this plus q charge. Okay, so here we can see that this kinetic energy of this charge, that is half mv square, that would completely convert into potential energy of that system. Okay, so when this would reach at this point, it is point P, then there will be only potential energy because at this point velocity would be 0. So there would be k q upon distance is r. So from here we can see that v square proportional to 1 upon r. Okay, because m, k, q, half, these are constants. Okay, so from here we can see that r is proportional to 1 upon v square. Okay, so in this way we can write that r1 upon r2 is equal to v2 square upon v1 square. So r1 was r, r2 as it is, v2 that is 2v, twice of initial velocity. That's here it is, okay, 2v. So it is 2v and it is v. So whole square is v. Cancelled out. So from here we can write r upon r2, that is 2 to the 4. So from here we will get r2, that would be r by 4. Okay, that would be the nearest distance. So closest distance, that is r by 4. So fourth option would be the right answer. Okay, I hope you got it.
Hello dear students. Now let's continue the discussion of the questions. The next question in the sequence is question number 41. It says, the figure given below shows the displacement and time graph of a particle which is moving along a straight line. So here we have displacement on the y-axis and time on the x-axis. Particle starts its motion here at time t equal to 0 and till time t equal to t naught, it is moving as shown in the graph like this, and after that it moves like this. So we know that the slope of the displacement time graph is going to give us the information about the velocity. So we just try to break down our journey into two parts, let's say from A to B first and then from B to C. So if I interpret the slope from A to B, So here I can say slope from the portion A to B, which is going to give us velocity. So here we can say slope, it is constant, and if slope is constant, so I can say my velocity, it is also going to be constant, right? Because it is a straight line, so I can say slope is going to be constant, and slope is giving us the information about velocity, so that is also going to be constant. Now from the region B to C, I can say here, since this B to C, it is parallel to x-axis, and we always measure slope with reference to x-axis. So I can say since BC is parallel to x-axis, slope here it is going to be 0, and if slope is 0, I can say velocity of the particle, it is also going to be equal to 0. So I think from AB to BC we interpret that initially our particle, it is moving with constant velocity from the region A to B, and afterward from B to C our particle comes in rest condition. So if we go in the option part, I think first option say particle is in acceleration throughout its motion. No, because we can see here velocity, it is constant, it is not accelerating, it is constant here. Afterward, second option say particle is accelerated continuously from time t0. Again I'm saying velocity is constant, so acceleration is not possible, so we can rule out option number 2 also. Third option say particle is at rest. Absolutely this is not possible, because here from A to B our particle, it is having velocity, but that velocity is constant, but still our particle, it is not in rest condition. Last option, particle moves at constant velocity. Okay, we can say from A to B our velocity is constant, and afterward, okay, it is moving with constant velocity till time t0. Okay, and then our particle stops. Stop means it comes to rest. So same thing is here, slope B to C, I can say velocity is 0, so I can say our particle comes to rest. So after going through all the options, the most appropriate answer, that is going to be option number 4, in which say particle, it moves with constant velocity from A to B till time t0, and afterward it moves, after that it comes to rest condition. Clear? I hope everyone is able to understand this question now. Now moving on to the next question in the discussion, it says question number 42, the temperature at which RMS speed of atom in neon gas is equal to RMS speed of hydrogen molecule at 15 degree centigrade. So apart from this, the question is also giving us the information about atomic mass of neon, that is 20.2 U, it is the atomic mass unit, and second molecular mass of hydrogen, that is 2U. Again U is indicating the atomic mass unit. Now based on this information, what we need to calculate, we are asking, the question is asking us the temperature at which RMS speed of both the gases, it's going to be same. So first of all we should know what's the basic formula for the RMS speed. So we all know Vrms, it has been given to us by this formula 3RT by mass of the gas, molecular mass of the gas. Now here the question is saying to us that the Vrms speed of which gas? So Vrms speed of neon gas, it is equal to Vrms speed of hydrogen gas. This is what the question is saying, right? Now apart from that, question is also saying, giving us the information about their atomic mass, right? Okay, so we are going to put here the atomic mass, but do note this thing very importantly, that the temperature that we are going to put here in this formula, that should be in Kelvin, and here the temperature that the question is giving us, it is in centigrade. So we know that if you want to convert temperature from degree centigrade to Kelvin, so what we need to do, whatever temperature is there in degree centigrade, to that we are simply going to add 273 approximately. So here temperature in degree centigrade, that has been given to us, it is 15 plus 273. So once we are going to find out, the temperature in Kelvin comes out to be 288. Clear? Okay sir. So once we got the value of temperature, now let's just try to proceed how we are going to find out the temperature at which speed of neon gas is going to be equivalent to temperature of, is equal to RMS speed of hydrogen. So simply we are going to put down the data here. So Vrms of the neon, so here I am going to use 3R, don't put down the value of this 3 constant, because ultimately it's going to get cancelled on both the side, into what's the temperature here. So temperature here it is, we need to calculate, it is T because we are talking of what? Neon gas. Atomic mass of the neon is 20.2. Same way, since both the speeds are equal, we are going to substitute here 3R. We are going to substitute here 3R, and temperature here it is going to be how much? Sir, temperature here it is, we already calculated that in Kelvin, 288, and its atomic mass is 2. So basically we need to calculate the value of this T. So what we can do, we can square both the side. So here we can also first can get rid of this 3R because it is common here, and after squaring, on squaring, we can say it's going to become T by here it is going to be 288 by 2. So we can again simplify this, and finally we are going to get the value of temperature as 288 into 10.1. And once we solve this, we are going to get the temperature, right? We are going to get the temperature as fourth option, that is 2.9 into 10 power 3 Kelvin. I hope everyone understood this simple formula based question in which we simply need to compare the two RMS speeds of hydrogen and neon, and after that subsequently by putting down the values in this formula, we need to calculate the value of temperature. Now the next question in the sequence is question number 43. Question number 43, it is saying air is pushed carefully into a soap bubble whose radius is r, and due to this air, what is happening, the radius which is initially r, it is becoming double. It means now it is becoming 2r. The question is saying if the surface tension of the soap solution is given to us, that is T, the work done in this process to increase the radius from r to 2r is going to be how much? Now here one thing we need to observe very carefully, that we are basically dealing with soap bubble. I hope you must have learned during the discussion in surface tension part that whenever it is soap bubble, in soap bubble we have basically two layers. In case of ordinary water bubble, we are just going to have one layer, but in case of soap bubble, we are going to have two layers, and because of that, the formula is also going to get changed accordingly. So here, the formula is pretty much simple. You must be knowing that we can calculate work done with the help of this formula. It is going to be 8 pi T R2 square minus R1 square. Directly, this is a formula based question. Work done in increasing the radius from r to 2r can be calculated using this formula, right? So here the question is saying the initial radius that is been given to us, it is r, and the final radius that is been given to us, it is 2r. So based on this part, we can say work done, it is going to be equal to 8 pi T. T is the tension that is already a question is given. So here it is going to be R2 square minus R1 square. So R2 it is going to become 4R square, and R1 square it is going to be R square. So here finally we can say work done, it is going to be equal to 8 pi T into 3R square. So upon solving, we can say right here it is going to become 24 pi TR square. So I think from all the option number 1, it is going to match the given part. Clear? I hope everyone understood this part. Now the next question in the sequence is question number 44. It's a basically assertion and reason based question. Question says given below are the two statements. One is labeled as assertion, that is A, and second is being labeled as reason, that is R. Question is saying, first of all, the assertion part we are going to read. Assertion part say Gauss law of magnetism states that net magnetic flux through any closed surface is 0, right? So basically we have already learned about Gauss law in electrostatics also, and we have learned about Gauss law in magnetism also. So according to Gauss law, we can say here integral of B dot ds, it is given to us. According to this statement, it says Gauss law for magnetism state that net magnetic flux through any closed surface, it is going to be equal to how much, sir? It is going to be equal to 0, right? Now, going towards the reason part of it, the reason which is going to support or it is going to oppose the assertion, let's just try to see that. It says that magnetic monopoles do not exist and north and the south pole always occur in pair, right? North and the south pole occur in pair, allowing vanishing net magnetic flux to the surface, right? So what does this statement mean? It means, first of all, we know that if we take the simple example of any bar magnet, so bar magnet always it is going to have two poles, that is north pole and south pole, and it is not possible to have just individually one pole. Always these poles are going to be there in pair, and we know that north pole we always assign pole strength, that is plus m, and to south pole we assign the pole strength minus m. And if we keep this bar magnet inside some closed surface, so definitely if I say what is the net magnetic flux coming out from this arrangement, so I can say net magnetic flux that is going to be there, it is going to be equal to how much, sir? It is going to be equivalent to 0, because here the net pole strength it is going to be 0, and if our net pole strength it is 0, I can say net magnetic flux according to Gauss law it is also going to be 0. So I think reason is completely supporting the assertion. So assertion is saying net magnetic flux is 0, and the reason is giving us the the explanation for that, and that explanation is since the net magnetic pole strength it is 0, so I can say net magnetic flux it is also going to be 0. So in this case we all know that both assertion and reason are true, and mostly this reason is the correct explanation of assertion. So here I can directly come on to this option 2, which says both A and R are true and reason is the correct explanation of A. I hope everyone understood this question. Now the next question in the sequence, that is question number 45. It says we have a monochromatic light, and for that light the frequency that has been given, it is 500 terahertz, right? It has been incident on the slits of Young's double slit experiment. Now the question says if distance between the slit is 0.2 mm and the screen is placed at a distance 1 meter from the slit, then the question is asking what is going to be the width of 10 fringes, right? So here apart from that the question is also saying that 1 terahertz it is equivalent to how much hertz? It is equivalent to 10 power 12 hertz. So in this question basically they are asking us what is going to be the width of the 10 fringes combinedly on the screen. So we know that the formula for the same fringe width we used to represent with the symbol beta, which is equal to n into lambda capital D by small d, right? Where n it is equal to the number of fringes. Here the number of fringes according to the question it is 10. Capital D it is a distance between the slits and the screen. So the value of this capital D it is given to us as 1 meter. And next small d, that is the distance between the slits, that has been given to us as 0.2 mm, which we can rewrite as 0.2 into 10 power minus 3 meters. Now only thing they haven't given us directly, that is about the wavelength. So we know that wavelength we can write this thing as c by f, where c, since we are talking of light and we know that light travels with the speed c, that is 3 into 10 power 8 meter per second. So we are just going to substitute that value here, 3 into 10 power 8, that is the speed of light. And what's the frequency? Sir, it's been given to us as 500 terahertz, that is 10 power 12, right? Now we got the value of lambda. I think we just need to substitute here in the formula. So upon substituting, we are going to get the value of beta. So that is going to be equivalent to 10 into 3 into 10 power 8 by 500 into 10 power 12, capital D that is 1, and small d is, what's the value of small d? Sir, 0.2 into 10 power minus 3 meters. So we simply need to do this calculation, and upon solving, the final answer that we are going to get, it is going to be 30 mm, which is option number 2. So again, this is the formula based question. If we are clear with this formula, then I think we can very well easily solve this question. I hope everyone understood this part. Now the next question in the sequence, that is question number 46, it says an AC source is there whose voltage is been given by the equation V is equal to Vm sine omega t, which has been connected to a pure inductor, right, whose value of inductance is L in a circuit where the peak value of current is Im. The question is saying, what is the expression for instantaneous power which is being supplied to the inductor, right? Okay. So here, first of all, before going into the details of this question, we should recollect that fact that whenever inductor is there in front of AC current and AC voltage, so in case of inductor, always current is going to lag behind the voltage. So according to the question, the voltage that is being given to us is, alternating voltage is Vm sine omega t. So if this voltage is being fed in the inductor, then I can say the current which is going to lag, it is going to be Im sine omega t minus pi by 2. Because we know, again I am repeating the same thing, in case of inductor, current always lag behind the voltage by a phase of pi by 2. So this minus pi by 2 is indicating the same, that our current, it is lagging behind the voltage by how much phase? By a phase of pi by 2. Now let's come on to the power part. So first of all, I think I can simplify this expression. I can write this thing as sine omega t minus pi by 2. I can write this thing as minus Im cos omega t, minus Im cos omega t, right? Okay. Now here, if I want to write down the power, so power we can write instantaneous one, it is going to be equal to V into I, right? Instantaneous power, I can write this thing, P is equal to V into I. I am simply going to copy down the values here, Vm sine omega t, and here this minus is there, so I am introducing here Im cos omega t. Do remember this Vm and Im are representing the peak values. Now here I just want to rearrange the expression a little bit. So what I'm going to do here, I'm going to multiply this expression with 2 and I'm going to divide this expression by 2. So it's not going to make any difference, but here I can rearrange it and say P instance means instantaneous power here. So here I can say P instantaneous, here it is going to become what? Sir, Vm Im by 2, and you can see here 2 sine omega t cos omega t. Now here power instantaneous, what I can write this thing as, minus is also there, so minus Vm Im by 2, 2 sine omega t cos omega t, I can write this thing as sine to omega t. According to trigonometric identity, sine to omega t is equal to 2 sine omega t cos omega t, so I can write this thing. And now we are just going to see which of the following option is matching. So here I can say first option, it is matching, that is minus Vm Im by 2 sine to omega t. So this is how we can calculate the value of instantaneous power. I hope everyone understood this part. Now the next question in the sequence is question number 47. In this question, in a meter bridge experiment, null point, it is at a distance of 30 centimeter from A. If resistance of 16 ohm is connected in parallel with resistance Y, then the question is saying null point occurs at 50 centimeter from A. Then the question is asking what is the value of this unknown resistance Y. Okay. Now we all know once null point has been obtained, it means the question is saying our meter bridge is balanced, and once meter bridge is balanced, we know that in this case resistance which are there on the opposite side, its product is going to be constant. So here if I say, let's say resistance of this meter bridge wire which is extending from A to B, resistance of this meter bridge wire which is extending from A to B per unit length, resistance length say let is L, let's say it is equal to rho. So in this case, the question is saying in the first part, when the length AJ it is equal to 30 centimeter, right? So I can say resistance of this part R AJ. We are saying per unit length the resistance is how much? Rho. So for the part AJ, the resistance it is going to be how much? Sir, it is going to be 30 into rho. For the unit length it is rho. So for 30 centimeter it is going to be 30 into rho. We can keep the values in centimeter because ultimately it's going to be a ratio. So it's going to get cancelled later on. Same way I can say resistance for the remaining part, that is R JB, it is going to be equivalent to the total length of the meter bridge wire is 100 centimeter. So if it is 30 centimeter, remaining it is going to be 70 centimeter. So it is going to be 70 rho. Okay, sir. Now if it is 70 rho here, because it is 70. In this next part of the question, okay, first of all, we got the value here. Now at null point, I can say at null point, the product of the resistance on the opposite side. So here I can say X, this unknown resistance, into R JB, it is going to be equal to Y into resistance AJ. So here X into R JB, it is equal to 70 rho into Y, resistance AJ, it is going to be how much? Sir, 30 rho. So this rho and rho went off. So X is to Y, value we got this thing as 3 by 7, or I can also say X it is equal to 3 by 7 into Y. X is equal to 3 by 7 into Y. This is the first part of the question. Now second part of the question says, now we have to connect a resistance R in parallel. And what's the value of R, sir? 16 ohms. So in that case what happened? Now the balancing point got shifted to 50 centimeter from A. Let's say this is the new balancing point P. Okay, so let's just try to discuss the remaining part of the question in the next slide. So here in that case what is happening? In that case I can say resistance R AP, it is going to be 50 into rho, and next say resistance PB, it is also going to be equal to 50 into rho. Okay, sir. We got the value of resistance. Now let's come on to the next thing, that is this event is happening once we are connecting a resistance R in parallel. So the equivalent resistance, I can write this thing when they are in parallel. I can say it is going to be Y into R by Y plus R. Okay, in this situation I can say resistance X into R PB, I can say here at null point, when our bridge is balanced, I can say R into PB, it is going to be equal to Y into R by Y plus R into RAP, right? Okay, so here X, which is going to be, let it be X only because we have to calculate that, RPB value it is 50 rho, YR by Y plus R. We are going to substitute the value of R in the last, so don't forget, so that we can ease the calculation, and RAP it is equal to 50 rho. So again we can get rid of the common term from both the side, and we also know that from the first part that we have solved, that the value of X it is equal to 3 by 7 Y. So let's just substitute here that value, since we know that X it is equal to 3 by 7 Y. So X it is equal to 3 by 7 Y, right, is equal to Y by R, YR by Y plus R. So here again we can get rid of this Y and Y. So now we can do that cross multiplication, 3Y plus 3R, it is equal to 7R. So I can say 3R, it is coming as 4R, right? Sorry. So here I can say directly I can take this 3Y, it is equal to 7R minus 3R, that is equal to 4R, it is equal to 3Y. So I can say Y value that is going to be there. So Y it is going to be equal to 4R by 3, and R value according to the question it is 16. So here the question is saying we need to calculate the value of this Y itself, 64 by 3 ohms, which is going to be our option number 2, 64 by 3 ohms. right? Okay. I hope everyone understood this point. Little bit calculation intensive question, but at least in the final part, once we substitute the value in the last, so I think calculation can be, minimized. Now the next question in the sequence is, two planets are moving in a circular orbit. The radius of their orbit is r and 4r, about a star. At a specific time, these two planets and the star, they are in a straight line. If the period of the closest planet is t, then the star and the planet will again be in a straight line after minimum time. How much? So the question is saying after how much minimum time, again the two planet and the star, again they are going to be straight line. So we know that according to Kepler's law, which governs the planetary motion, one of the laws says t square is proportional to rq. So we are going to make use of this law and we are going to solve the question. So first thing, the question is saying when the radius is r, the orbit time period, let's say it is equal to t as per the question. For the second case, when the radius of the orbit is equal to 4r, we need to calculate the value of time, right? So here we can directly make use of this relation, say t1 square by t2 square, it is going to be equal to r1 by r2 whole cube. So once we substitute the value here, t1 by t2 whole square, r1 value is r, r2 value it is 4r whole cube. So we can get rid of this, and here initially t1 is t, so I can say here t square by t2 square, it is going to become 1 by 64. So here I can say t2 square, it is going to be 64 into t square. So we can take under root, so t2 it is going to become 8t. That is option number 3. Now the next question in the sequence is 49th. It says a string of length L is fixed at both the end and it is vibrating in second harmonic. The amplitude at NT node is 2 mm. Now the question is asking us what is going to be the amplitude of the particle which is located at a distance L by 8 from the fixed end. So first of all we should know how our thread which is going to look like when it is vibrating in second harmonic. So if I say these are the two fixed ends and our thread it is vibrating in second harmonic. So let's say initially our thread it is straight when it is not vibrating, and afterward if it is vibrating in second harmonic at some instant, so it is going to look like this, right? So here I can say L it is going to be equivalent to lambda. L it is going to be equivalent to lambda here, right? Now here the question is saying we need to calculate this amplitude for the particle. Let's say there is some particle here, we need to calculate its amplitude and it is located at x is equal to L by 8. We need to calculate the value of this y. So we know the equation of the string wave which is equal to y is equal to 2a sine kx cos omega t, right? Where k we always know it is a constant which you call it as propagation constant, which is equal to 2 pi by lambda. So here we can say this complete length of the string it is going to be equivalent to lambda. As we can see here, this is lambda by 2, so I can say total it is going to be equivalent to lambda here. So once we are going to substitute the value, we need to calculate the value of this y, displacement 2a. The value of this is the amplitude that has been given to us as how much? 2 mm. So this is 2 into 10 power minus 3 into sine k, it is 2 pi by lambda into x that has been given to us how much? L by 8. So we already know that lambda it is equal to L, so we can substitute here instead of this lambda directly L here, cos omega t. Now since we are interested in the amplitude part here, So this expression is going to be equivalent to the amplitude here. So directly I can write here y it is going to be equal to 2 into 10 power minus 3. This is going to get cancelled, pi by 4. So sine pi by 4. So once we substitute the value of sine pi by 4, that is equivalent to 1 by root 2. So final expression that we are going to get, it is root 2 into 10 power minus 3 or 2 mm. This way we can calculate the value of amplitude of the particle which is located at a distance L by 8. So this is the final expression. I hope you are able to understand this. Now the next question is question number 50. Determination of the value of acceleration due to gravity, that is g, by simple pendulum method employs the formula g it is equal to 4 pi square L by t square. Now here we know that this 4 pi square, it is a constant. Basically g value depends on L and t, right? How? It is proportional to L and inversely proportional to t square. Now the question is asking what is going to be the expression for the relative error, right? Now we know that irrespective whether g is proportional to L or g is inversely proportional to t square, errors are always going to get added up. So if I say in this expression how it is going to be like that, so I can say relative error, which we can write this thing as delta g by g, it is going to be dependent on L. So here nothing is there, so I can assume the power it is 1. So 1 into delta L by L plus this power is there. Again I'm telling, since it is inversely proportional, it does not mean it is going to be minus. Errors are always getting added up, so it's going to be 2. This power it is going to come in the front and it is going to be delta t by t. So based on this part we can directly go for this option number 4, that is delta g by g, it is equivalent to delta L by L plus 2 delta t by